Hi everyone, welcome to my talk. And today I will be presenting batch and streaming in the world of data science and data engineering. So this sounds like a very big title, just try to cover everything. But what I hope through this talk is to provide some introduction of batch and streaming from the perspective of data scientists and data engineers. So a little bit about my background. I'm a data engineer at Capital One. Before that, I did a fellowship at Inside Data Engineering, where I learned all those big data technologies. And I got my bachelor and master degrees in systems engineering from University of Virginia. To get started, the first question I want to answer is, what is batch? What is streaming? So there's one analogy I really like is it try to compare the water in the river try to compare data as the water in the river. So batch is as if you deliver the water in a bucket to a user, while streaming is you try to deliver the water through a pipe, so it's more continuous. So the first thing I want to talk about is predictive modeling, and also what batch and streaming means for predictive modeling. And later I will transition into more of the engineering perspective. So the task we are trying to do here is trying to predict whether a given URL is a phishing website or not. So what is a phishing website? Basically, it's something that's actually like a malicious, but it looks like a real website. All we're trying to do is steal your personal information. So the example I have here is you have this Facebook login page, but if you pay closer attention to the URL, you can see it's actually some random URL, and if you put in your username and password, it's probably gonna send to some bad guys and use it for bad reasons. So when you try to train a model that predicts whether a given URL is good or bad, you will perform some sort of feature extraction. So basically, features a set of thing that describes your data set. In our problem, it can be the length of the URL, and also maybe the age of the domain. So the longer the domain has been around, the more legit it is usually. And also whether there's a prefix and suffix attached to a domain. So when you try to train so the problem we're trying to solve here is a classification problem. So you can use like logistic regression or random forest. And when you try to train a model, you usually just split the data you have for training set and test set, and iterate through the training process and the validation process. And eventually you will have a model, and you can save that model to file. What that means is if you're using Python, it can be like a pickle file. If you're using Java, it can be like a POJO. So after you have your model, you want to do your prediction. In a more traditional way, you can do your prediction in a batch or offline fashion, which means you have more data points coming to your system, and every night or every week you run your prediction, use the model you trained, and produce this outcome. However, let's say for this predict of the phishing website, you probably want it to be more real time. Let's say if you have like an email system, you want to alert your user, okay, this URL looks very sketchy, probably don't click on it. And then you will, if that's the case, you will probably deploy your model in your streaming pipeline. And as the data comes in, it will do the prediction and have like the instant output of that data point. Another thing you will think about is for model updating. As your system keeps running, you will receive more and more data. And then how would you want to incorporate that data into a model? So you can definitely do it in an offline fashion, which means that you retrain your model with your historical data and also the new data you got from your system. And then you do that every night or every week. Sometimes this can be challenging if your data set is like too big. And alternatively, you can use online algorithm and also potentially do online learning. So basically, for every new observation comes in your system, if you have feedback for that URL, for example, if a user flag this URL is actually bad, you can actually update your model right away for that given data point. And one of the advantages of this method is you can adapt to the new trend of the data sooner. And then there's some kind of like middle ground is the batch or mini batch. Basically, let's say you wait for every 1,000 observations, then you update your model with that. So I have like a quick demo about how online updating will look like for you if you just, let's say, deploy a naive model, does this like 50-50% guess, but as the online updating keep happening, you can see the model accuracy get improved. So I wanted to do a lab demo, but I have this fear of like lab demo that never works. So I just like recorded it, just make sure everyone can see it. So basically, what happens? I have this like a streaming system, and then I have this model deployed in a streaming pipeline, and this is just like a front end that plot the accuracy of the model, and then the red line is the accuracy of the model of the process that has the pre-trained model already. And then the blue line is the accuracy of a pipeline that's, you have a naive model to start with, and as more data comes in, you do this online updating. So you sort of can see when it started, the accuracy for the naive model was like 0.5, 0.6. But as more and more data comes in, the accuracy actually is like improving pretty nicely. So for this short demo, I used Spark streaming. So for Spark 2.0, it has this feature to save model to a file. And as we mentioned before, we use the logistic regression for this classification problem. And then you can train your model and save your model. And later on, when you want to do a prediction, you can load this model from file, either for your batch prediction or online streaming. And another part is this online learning part. Basically, you have this update function that will call on every RDD, and then it will update your model based on the new coming data. So couple takeaway for online algorithms, there's always pros and cons to like almost everything. So for our algorithm, it's usually computationally much faster. And also, it can be helpful when the data set is too big, you can just update your model in a small chunk. And also it adapts to new trend a lot faster than if you do everything in a batch or like offline fashion. However, the disadvantage of it is like majority of the algorithms themselves can only be performed in batch. And so online algorithm itself is a separate research field that people constantly invest their time in. But we're not gonna talk too much about it today. Another thing you will need to think about is for your feature extractions. Sometimes feature extraction can be slow, and it will affect your any like streaming process, whether it's the prediction or whether it's the model updating. So one example I put up here is, let's say there's IP address in your data set, and you are curious where this actual location is at. There may be some external API you can call with this IP and get a geolocation back. However, if you use that as your feature, then the feature extraction time is dependent on this external API. But there are definitely like many ways to work around with it. Maybe you can just pre-populate your database with this IP and geolocation lookup so you don't have to rely on this external resource. And sometimes if you don't have any way to work around that, you will need to think about, well, do I really need that feature? Or maybe I can just change this into some feature that's faster. Another thing is it can be hard to always get things right in an automatic way. If you do online learning, sometimes you have less control of the data that goes into a system. So you can't really like massage it and then play around with it and decide whether I want to feed that into a model or not. It usually just goes into a model. However, your team decide, well, we want everything real time and we want everything streaming, whether because you want like a more real time decisioning system, or whether because streaming just looks so cool and everyone else is doing it. So you decide to do that. But just keep in mind, streaming is cool. It can be a little bit challenging try to build and maintain a streaming pipeline. Then you are curious why that's the case. So this is kind of, I'll first talk about like how to build a streaming pipeline. This is like a very bare minimum streaming architecture. Basically, you have this queuing system that queues up the message that goes into a pipeline. And then you have this streaming processor. In my demo, I used the Spark streaming, but it can be a Storm or like Flink, so whatever you want to use. And then you will save the output of your processor into a database. Here I use Redis. Redis is basically like an in-memory database. And eventually you will have your like consumer, or like it can be either another API or like a front end that reads from your database of the result you produce. I want to talk a little bit more about Kafka. So Kafka is a queuing system. You can use other things like Kinesis, but the reason you need a Kafka there is for like two major reasons. One is it acts as a message buffer. And sometimes, for example, if the message doesn't come into a system in an evenly distributed manner, so this hour there's like a ton of messages, and the next hour there's only a few. So you want, like, if your streaming processors did not process them properly, it's nice to have this buffer so that like you can queue up your messages, and then your streaming processor can pick it up later. And another thing is, Kafka also keeps logs of the messages, which is nice. This will be useful when, let's say, your Spark cluster just went down, and then you don't want any of your messages get lost because your cluster went down. So it's nice to have this like a record that's kept in Kafka. When you have another Spark cluster that went online, you can just read from Kafka again and then just keep processing. So then streaming pipeline can be a little bit challenging because of the nature of the data stream itself. Events come into a pipeline usually unordered, so they can come out of like in different order. And also there are always gonna be duplicates for your data stream. And another thing is the data stream is unbounded, which means there will always be new data points comes in. So the nature of the data stream makes you think about how you would reasoning about time. So there's two major concepts in a streaming pipeline. One is event time, one is processing time. So event time basically is when this event actually happens, whether a user clicked something on their mobile app or whether they clicked this link on the website. So that's when this event actually happens. While processing time is when this event arrives in your system and you actually process it. So we can see that sometimes when the event happens first, it may actually arrive in your system like later. So because of that, when you try to build a streaming pipeline, you will want to think about whether event time matters to you or not. Here, this is kind of like a spectrum of like where the event time doesn't matter that much to where the event times like matters. So from the first is those applications I call them like time agnostic. Basically, you don't really care when this event happens, but when it happens, you just need to know. The example I gave here is at Capital One, we have this application called Second Look. One of the features is called generous tip. So for example, when you go to a restaurant, you accidentally give like 50% of the bill as the tip. Maybe you really like the waiter, or maybe it's like a mistake. It can be nice. You get this notification right away from your from a text message or your email, so that you can correct that when you are in the restaurant. So in this use case, like you don't really care when the event actually happens. It's more about, okay, when this thing arrives in my system, I process it and then I send my user a notification. And something in the middle ground is those problems that you can use some sort of approximation. So let's say for a credit card company, you are curious, okay, what are the top merchants my customers shopped at in the past hour? So in this case, you probably don't need to get like a 100% accurate count. It's more like, okay, maybe I get it right, even if I lose 1 or 2 messages, it won't affect my outcome. So in this use case, even if you use processing time, it wouldn't really affect your outcome that much. However, there are also use cases when event time actually matters a lot. The example I give here is for second look, there's another feature called double swipe. Basically, sometimes merchant will accidentally swipe your credit card twice, and we will send our user notification, say, okay, take a look at this again, like is this a mistake? So in this use case, event times matters more. Imagine a situation if I went to a grocery store, I bought a bag of coffee, 20 minutes later, I'm like, well, I actually need another bag because I just need a lot of coffee. And I went back there again, bought another bag. So for the event time itself, there's 20 minutes in between. But if the first event that arrived in your system a little bit delayed, then the processing time may not be that far away from each other. So if you send user notification based on processing time, it won't be that accurate. And another thing that event time is important is when you try to do the duplication of your data stream. So like duplicates happens for all kinds of reasons, but when you try to deduplicate them, and you see that the event content is pretty much the same, and if the event time is also the same, that's more likely to be a duplicate. So another thing you will consider when you try to build a streaming pipeline is the correctness of message delivery. So there are various guarantees you can give when you have this pipeline. One is, so first is at most once delivery. So basically you allow some potential data loss. It's like, so when you have a pipeline, you have this Kafka, you have Spark streaming, like when the message get passed between them, like can you guarantee the message actually go through from Kafka to Spark streaming? It's like you mail a letter to a friend, and most once is if you mail them once and you don't care whether they got it or not, it'll be great if they got it. If they don't, that's okay. Another real world example is when you send the video data through the internet, it's okay to lose couple like video frame. It probably wouldn't affect your end users kind of experience that much. Another guarantee you can give is called at least once. So basically you allow some potential duplications, but you don't want any message to get lost. So the picture on the right is kind of like an illustration of that. You just keep sending the information until you are sure the other end gets it. So it's like you write the same letter 10 times just to make sure your friend gets one of it. The most ideal world is exactly once delivery. So basically you send an email or you send a message and then the other end, like it receive it at the same time. However, exactly once can be a little bit challenging to implement. It usually requires a little more of better configuration of your infrastructure. So one thing you want to make sure is sometimes your machine fails, like how can you guarantee the consistency when a new machine comes up? So a couple of takeaways for why is it challenging to have a streaming pipeline. First is the challenges come from the data stream itself, and how you want to handle time usually depend a lot on your use case. And so when you work in a team for both data engineers and data scientists, it's nice you communicate and think about what actually matters to you. So event time usually reflect the real time more, but it can be a little bit harder to implement. Because for example, if you want to do some aggregation of the event happen in 15 minutes, then it may require your like 30 minutes processing time because some message may arrive in your system with a little bit of a delay. And then the second is like there will be challenges from your infrastructure itself. So how can you guarantee from one system to another the message actually goes through? And exactly once delivery is very important for your analytical results. And you probably want that for like this online learning process because you don't want duplicated data feed you into your model, and you also do not want to lose like important data points. But overall, streaming does give you a more timely results. However, also keep in mind that not everything needs to be real time. One example I think about is when you place an order from Amazon website, like they don't have to process it right away and ship to you like right away. It's okay for them to wait to the end of the day and aggregate all the orders they receive from one user so that they can actually package up everything they want and ship them in one time. So just kind of think about when you have a problem, whether you want to do it in batch or streaming, just a couple things to keep in mind. First is model updating. Batch improves the accuracy every time you retrain your model. Online updating actually can adapt to new data points as they come in. It kind of ties to the second point for latency and correctness. So batch definitely have higher latency, but you usually have a little bit more control of the data of like what actually goes into your training model. And so streaming, you have the lower latency that like the data outcome can come up faster, but you do have like less control. Another thing I want to mention here is monitoring. So if you have a real-time model that deployed, you probably want to monitor the accuracy of the model so that if something goes wrong, let's say your accuracy all of a sudden gets really low, then you can like actually go back and take a look. Did my data stream changed, or is there something wrong with my with the model itself? Another thing is the maintainability of the pipeline. So it is easier to maintain one pipeline rather than two. So if sometimes if you have a batch pipeline and a streaming pipeline, but their functionality are sort of similar, it's actually nice to just do everything in a streaming fashion. And if anyone's interested, there's articles on like Lambda architecture and the Kappa architecture. Basically, Lambda architecture is this that has like batch as this source of truth, and then streaming pipeline is kind of provide more real-time decisioning along with the batch, and then eventually you will have a unified results. However, Kappa architecture, it only maintains a streaming architecture, and batch is kind of built on top of the stream. So I am a data engineer myself, but I always kind of like passionate of bridge the gap between data engineer and data scientists, and I think it's important when the two group of people work closer together, then they will come up with a better solution. So here's is kind of like my take on what's the difference between data science and data engineers. So data scientists, they usually have a better understanding of the data set itself, whether like how to find the right features, how to get the label data, and how to like develop a model that can be used to solve your problem. While data engineers, they usually like more curious about like, oh, how do I build this streaming pipeline? How do I guarantee this exactly once delivery? And also some middle ground is like it can be like Spark programming, and also like whether event time or processing time, which one matters more. So those are kind of discussion both group will think about. And here are kind of a list of resources of the things mentioned in my talk. I have the kind of like the GitHub repo for the small demo I have. You can take a look if you're curious of using Spark machine learning library to do this online updating. And also the second is the data set itself. And the following couple ones are the reading material. If you're interested in streaming and interested in how to build like a streaming architecture, those are the things you can read about. So this wraps up my talk, and I'll take some questions.
You mentioned that correctness is better with batch than with streaming. But you have a Spark processor, right? Doesn't that processor validate the right events and discard the bad ones?
Okay, could you repeat the question again so that I make sure?
You mentioned that correctness is a feature of batch, but not of streaming.
I would say correctness, you can have correctness guarantee from a streaming pipeline. So this exactly once delivery is where you actually guarantee the correctness of your streaming process.
Okay.
Yeah.
Any other questions?
You mentioned, sir.
So regarding the online training, you mentioned only certain algorithms support online training right now. I see in your example, if I recall correctly, it's a logistic regression or something,
Yeah.
right? So I was just out of curiosity, just in addition to logistic regression, what other algorithms are currently supported? And also, my second question is, I see you're using Spark streaming, right? Well, if I'm just using simple scikit-learn, does that framework support any online training at all?
Yeah, so I'm not a data scientist. I'll answer from what I know. So besides logistic regression, I know a support vector machine that also have this online algorithm. But what it does is this what optimization method you use. So here you use this stochastic gradient descent, which you can make an improvement of your model for every data points. Rather historically, you have this gradient descent that trains thing on every data points in your data set. So that's kind of what makes it online, which is you can act upon every single data point. And with that being said, I think scikit-learn will definitely have this stochastic gradient descent implemented. Although I don't usually use it, so I can't say it for sure. Yeah.
There's one more question here.
You mentioned don't mix and match for the same functionality between batch and stream. It was towards the end of your presentation. And I forget how you put it. It was one good stream is better than two.
Yeah, so the lambda and the kappa architecture, right? So lambda is the one has two. So the reason behind that is if in lambda you have this batch and streaming, it does pretty much the same thing. But from an engineering perspective, it's really hard to maintain. You have to have provision your server to do the same thing, and you have two sets of servers that does exactly the same thing. However, Kappa is using a different alternative way. It keeps all the events coming as event log, and then you can do that in real time by just consume the log right away, or you can do a batch fashion. Basically, after you have all those logs, you read from the very beginning, and then gets all data points together and perform this batch process.
So actually, my question was going to be at Capital One, your goal is to get everything on a stream, right?
Yeah, we want to do things in stream. There are some applications.
Does it mean that does it mean that if it's streaming, you're directly processing the raw data, whereas if it is batch, you're collecting the raw data somewhere and then processing it in batches of time?
Yeah,
is my understanding correct?
Do that, yes.
All right. Okay.
All right. Any other questions? All right. Thank you, everyone.
Thank you.